Welcome to the lecture on Introduction to Compound Interest. So, in the lecture which has been completed, we discussed about interest, and especially the simple interest was introduced, and in that basically we also discussed about the discount rates and how to calculate the simple interest and all that. Now, we will have the introduction about the compound interest. Now, as we see that unlike the simple interest method, in the compound interest method, interest is earned on the principal as well as on any interest earned. So, that is what happens in the case of compounding, that as the time moves on, the interest amount does not remain fixed, which is the case in the case of simple interest, because in the simple interest basically it will be depending upon the first value, and there will be certain percentage of that is the rate of interest, and that is multiplied with the time. However, when we talk about the interest earned even on the interest, so then it is defined as the compound interest. Now, if you talk about for example, if you have suppose 1000 rupees you have invested, and if it is simple interest, so that this way you can see that if you have suppose rupees 1000 is there, and if you take the simple interest method, then if time is going like 1, 2 or 3. So, your principal amount is basically remains to be 1000. So, this is and then if you see in the first year your interest will be, if the rate is 10% suppose. So, this will be basically 100, second year also 100 and third year also 100. So, ultimately your total interest becomes 300. So, this is simple interest, and you have to pay 1000 plus 300, that is 1300. So, you have to pay 1000 plus 300. So, this will be your future value, and that will be 1000 plus 300, that is 1300. So, that is there in the case of simple interest. Now, the difference between the compound interest is that you have in this case your time goes like 1, 2, 3, and in this case the principal at the first year. So, first year it is 1000, and interest earned is certainly at 10%. So, interest will be 100. Now, in the second year basically this 100 is added, and 100,000 plus 100, that is 1100 becomes your principal amount, and then that on that basically you are getting at the rate of 10%. So, it will be 110. So, in the beginning of the third year your principal amount becomes 1100 plus 110. So, it will be 1210, and again on this you have 10% of interest earned. So, it will be 121. So, it becomes 1331. So, this is the difference you get when you are basically calculating even the interest on the interest earned, because this is the interest earned 100, and in the case of compound interest basically this is the interest is also calculated on this 100. So, in the earlier case basically your interest earned was only 100, whereas in this case interest earned is 10% of 100 also extra, that is 10. So, 110 plus 10. So, that way the things change, and then again plus 11 next time also. So, ultimately 221 is the extra that way. So, 331 comes. So, this is 1331 comes like that. So, this is how the difference between the simple interest and compound interest can be understood. Now, many times what we see is that in the companies, if you try to see the look at the value of these money. So, what happens that the future value will be the current value plus R into current value. So, if we try to see that how they are changing graphically, basically you can further see that if you have any amount, so it will be changing, and when we take up the simple interest rate. So, if the n is moving like this and you have invested some amount, suppose at this point. So, now when you have a 5% interest, it will move like this. So, this is going to be the case when you have the simple interest cases like in 5% or in 10% or in 20% or so. So, that way it will move, whereas if you take the example of the compound interest. Now, in the case of compound interest, this value basically is going to change, like if you have n going like this. So, this 5%, so this move like this, then 10% will move like this, 15% will move like this, then so this way your 5% or 10% or so. So, this way, so you can see that this is straight increase, there is a proportion, so there is a slope which is a fixed one, whereas in this case as the time increases, that goes on increasing. So, that is what is the change in the value as we move with time. So, this is its value as it changes with time. So, what we can see that in the case of simple interest, basically we were calculating like f equal to CV into 1 plus R n, 1 plus R into n. Now, that was the case in the case of the simple interest. Now, if you take the compound interest, what happens that you have FV is, as we know, that if you take for year. So, FV initially at the end of year CV into 1 plus R. Now, this is going to be in the first year. Now, when you go to the second year, then what will happen? So, in second year, so in the first year it will be happening. In second year, what happens that your future value. So, this will be your present value. So, CV into 1 plus R plus basically your rate is R%. So, R into CV into 1 plus R. So, what you see that you get CV into 1 plus R is common, and then comes 1 plus R. So, it will be CV into 1 plus R raised to the power 2. So, in the end of the second year, your future value becomes FV is CV into 1 plus R raised to the power 2. So, this way your future value will go on changing, and basically at the end of the n years, if there are n years, so you have a general formula that FV. So, after if the term of maturity is n years, in that case it will be CV into 1 plus R raised to the power n. So, that is how you are basically calculating this future value. Now, so this is in the case of the compound interest. Now, you can have the problems based on such, like someone has invested for some years, then what will be the future value at some rate of interest when it is compounded annually. So, when that term is mentioned, annual compounding is mentioned, in that case you have to use these terms, use this equation. So, if the current value is given and R is given and N is given, so you have to use them. and that way you have to use with this factor 1 plus r raised to the power n. So, basically this factor will be you can also get it. So, there are factors, this will be also present or available to you in the form of tables. So, simply you have to multiply with that factor and you can directly get the future value. So, that is how you get these values in the case of this compound interest. Now, similarly, so in this case you are getting the future value. You can also calculate the current value also. So, if you just reorient this equation, you just try to find current value, it will be nothing but f v divided by 1 plus r raised to the power n. So, basically when you have to find the current value, to find current value. Now, in that case basically you have to use the similar equation. So, you have the current value will be f v divided by 1 plus r raised to the power n. So, so this is C v will be f v divided by 1 plus r raised to the power minus n, or you can also write f v into 1 plus r raised to the power minus n. So, this is the factor which will be basically multiplied 1 plus r raised to the power minus 1. This is nothing but the reciprocal of the factor which have been used to find the future value from current value. So, it is just a reciprocal of it, and this is used to find the current value from this future value which is available to us. So, again if you know the future value, someone has to achieve some future value in certain time, and the rate of interest, that the compound interest, is known. In those cases you can use this formula and you can get it. Suppose somebody has to inherit some amount in certain years. So, how much he should put now in cash. So, that is at certain compound interest per annum he should get that amount in 5 years suppose. So, in that case 1 plus that rate which is given, that value divided raised to the power minus 5, and that should be multiplied with that future value which is to be inherited. So, that will give the amount which should be invested now in the bank. So, this way you can solve such problems easily. Then, similar to what we discussed about the discount factors, or in what we saw in the case of simple interest, here also you must know what is the discount factor. So, again if you go to the definition of the discount factor which were discussed in our earlier case. So, so it I mean this will be that factor which current value. So, that is to be multiplied, so that you get it you get this current value. So, that future value has to be multiplied with that, and that is known as the discount factor. So, this is it is known as that future value can be logically discounted to a current value. Okay. So, basically you are discounting this future value to a current value. What should be the current value which will give you that future value? So, that is discounted to the current value by, so you are multiplying this future value with certain factor, that is your discount factor. So, by being multiplied with a certain discount factor. So, that is the factor which is known as the discount factor, and it will depend upon the rate of interest and also the time of maturity, and that is how. So, that is basically 1 plus r raised to the power minus n or 1 by 1 plus r raised to the power n. So, your discount factor becomes, as we discussed, that this discount factor becomes 1 by 1 plus r raised to the power minus n, and this factor is known as the discount factor. Now, we will see that how to how, if such problems are coming, like how to find the rate of compound interest. There may be, so you have just to reorient these expressions, and you can find the value of the rate of compound interest. So, finding the rate of compound interest now, you see we have the expression between f v and c v, and we know that f v equal to c v into 1 plus r raised to the power n. So, f v will be c v into 1 plus r raised to the power n. Now, if we have to find the rate of interest, that is r, so 1 plus r raised to the power n will be f v by c v. So, if you try to get the expression for r, basically r will be 1 plus r raised to the power n will be f v upon c v. So, r will be again 1 will be subtracted from that. So, f v upon c v raised to the power 1 by n will be 1 plus r. So, it will be f v by c v and raised to the power 1 by n minus 1. So, this will be the rate of interest. So, there may be cases when you want to know that at what rate of interest you should invest, so that in certain time you should have the amount being multiplied to certain certain factor, by being multiplied by certain factor, like it should be 2 times or 3 times or 4 times. So, how much you will be the rate of interest, so that it becomes it has a certain ratio. So, f v upon c v, it also can be written like f v and by c v, and then its nth root minus 1. So, you can also get such kind of expressions, and you can find this rate of interest. So, suppose there is a offer that or there is a question that you want to buy a car for suppose say in 1,50,000 rupees or maybe 15 lakhs in certain 5 years suppose, and you want to start investing now. So, and you have some amount which you can invest. So, at what rate what should be the interest rate that will give you that much amount after 5 years. So, in such cases simply r can be found by f v by c v, and then you can have this value computed. So, that will give you this rate of compound interest, which should be applied, which will give you certain f b by c v ratio. Similarly, another thing which can be further required is finding the compounding term. Now, so only one thing is left, that is n, and again if you want to find n, so n will be basically ln f v upon c v divided by ln of 1 plus r. So, basically you have again we know that f v equal to c v into 1 plus r raised to the power n. So, f v by c v will be 1 plus r raised to the power n. You have to take a log on both the sides. So, log ln of f v upon c v will be n into ln of 1 plus r. So, this way n becomes equal to n comes equal to the here. So, n will be this upon this. So, this way you can get this compounding term, that is your ln of Fv by Cv divided by ln of 1 plus r. So, that way you get so suppose you have to the rate of interest and the future value and the current value. So, by using this expression you can directly get the in how many number of years in how many number of years you will get a certain ratio of Fv and Cv at a particular rate of compound interest. Now, many a times what we see is that we need to know that normally we are interested to know that when our money will be doubled or when our investment amount will be doubled or tripled or so. So, for that there are very standard rules, and so we discussed about the discount factor. So, it is determined by both the interest rate and term of time during which the future value is pulled back from future value to the present time. So, that is how discount factor was discussed, and then there are rules of 72 and other rules. So, we are going to discuss about the formulas which are used basically which will be estimating the time required for a principal value to grow to any factor. So, what happens that many a times we are interested to know that when our investment amount will be doubled or tripled, and for that there are simple formulas, and the formula is that this n, the time during which your investment amount will be growing by a factor. So, it will be 72 by r for 2 CV, when the future value has to be 2 CV. For 2 CV means the future value has to be 2 CV. So, Fv by Cv will be 2. So, for that n is 72 by r. So, for any rate of interest, suppose if r is 12%, it means n will be 6. So, when the rate of interest earned is 12%, in that case if you are putting an investment amount now, suppose 1 lakh rupees we are investing now, then and the rate of interest earned is suppose 12% compounding annually. In that case, in 6 years we are going to get the 2 lakh rupees of that. So, that is what it is telling, and this is known as the rule of 72. And if suppose we want to go to triple our amount, so if 1 lakh is to be converted to 3 lakhs. So, for that the rule is n equal to 114 by r. So, this is for 3 times the current value. So, future value by current value ratio will be 3, in this case Fv upon Cv is 2, or in this case Fv upon Cv will be 3. So, these are basically the rules. If you are going further for 5 Cv, so n will be basically 167 by r for 5 Cv. So, these are the rules basically which are used to calculate that for a particular rate of interest in what amount. So, suppose somebody has to double the investment amount, in that case at particular, suppose 10% is the rate of interest, in that case it will be 7.2 years, or in this case for 3 CV 10% is there, so 11.4 years, like that. So, this is the meaning of the rule of the 72 years, and in that there is further we can have suppose what happens that sometimes the we have to see that we want to have the this our investment amount to be increased to 30-fold. So, for example, so we can have that suppose we want to have investment grown by 30 times. Now, in that case what we do is that normally we have to see that we have to convert these 30 into factors, and we have to break down these factor into the, so that is into multiples, and then there are rules by which you calculate. So, suppose this 30 if you calculate, so it is to be 30 will be put into the number of factors. So, it is as 2 into 3 into 5. So, you know, so that 72 basically we know that 72 is the number of months, you know, that way. No, that is different. So, you have 30 is equal to 2 into 3 into 5. Now, the rule is that n has to be rule to double, then rule to triple, and then rule to grow 5-fold, and this divided by r. So, this is what the rule becomes. So, as we know that in earlier case it was 72 r n is equal to 72 by r. Now, in this case you have rule to double, rule to triple, and rule to grow 5-fold. Now, as you know that rule to double is 72, then you have you know rule to triple, for that you require 114 is the you know in the numerator. So, you have 114, and for 5-fold you have 167 divided by r. So, if you add them it will be 186 plus 167, it will be 353 by r. So, now if you know if you look at that, if your rate of interest is suppose 10%, at that 10% what will be the time required when your investment will be 30 times. So, it will be 35.3 years, or if it is suppose 12%, then it will be 353 by 12. So, for 12% rate of interest it will be coming as 353 by 12 years. So, it will be something like 29.4 years. So, this is how you are calculating those number of years basically in which the amount will be basically you know changing. Now, apart from that, when we do talk about compounding, so in that compounding there is also that normally by default we feel that the compounding is done annually. However, compounding can be done at any interval. So, you may have compounding at you know frequent intervals of time, and that may not necessarily be 1 year. So, the compounding may be after 6 months. So, you have for the you have annual compounding. So, that is you know so you are doing compounding once. You have you know semi-annual compounding, which you are doing the compounding twice. You have the you know quarterly compounding. So, quarterly compounding means you are doing the compounding 4 times. So, basically you when you do the normal compounding annually, so in that case your interest rate is fixed. You know that 12% is the interest rate for a year. But when there is compounding for 2 years 2 times, in that case 6% is used after 6 months. So, so for example, if you look at in that case, so 100 will become 106 after 6 months, and then after 6 months further you will have multiplied this with again 1.06. So, that way you will have 112.36. So, basically your effectively you are getting the interest more. So, if you are being charged, you are paying more, or if you are receiving, then you are receiving more than 12%. So, that is basically the effective interest, and this is because of the number of times this compounding is carried out. So, because of that you have a different terminologies, like you have the effective interest rate, and in this case as you see that the effective interest rate becomes larger, and it depends upon how many times the compounding is being carried out. So accordingly the effective interest rate will be calculated, and that gives us that what is the effectively you are being charged the interest rate. So this is about the compound interest, and we will in our coming lectures we will discuss about different type of compounding factors, and we will also deal with those situations how depending upon the payment at different times of different amounts or so, how this compounding is being done, how these cash flow diagrams look like for such cases. So that we will discuss. Thank you very much.